The 5 Series MSO started a number of years ago with the goal of enabling new capabilities for our customers.
It's very much a brand new architecture that has been built from the ground up.
The biggest challenge is this is a new platform. It's a new software platform, a new mechanical platform, a new hardware platform, new ICs.
Everything about this platform is brand new.
There's been a lot of new things for everyone to learn, but the biggest challenge is that all that new software and all that new hardware is being developed at the same time. There's a number of ways we can mitigate the challenge of bringing up the hardware and software at the same time. We've done a lot of simulation of the hardware in software, so we can write a lot of software simulation so that when the hardware eventually arrives, the software knows what to expect. It may not work perfectly, but we've done a lot of simulation, so we don't have to start from scratch.
Lots of challenges. From a time to market standpoint, just the sheer amount of work that we had identified that we wanted to accomplish within the time frames that we wanted to accomplish them was in itself quite a challenge.
What's most exciting for our team about this chip is the high fidelity portion of it. It's never been done before. We were integrating DSP engines into the chip. The algorithmic design was unique. We were able to attract top talent because when we sent out to the world that we were developing this, the people came from all over the world to say, we want to be part of this solution. And we were able to build the best team. And with that group of people, with our partners, we were able to deliver the highest fidelity chip that exists on this planet.
So we put a lot of effort into making sure this is a very high resolution instrument. Going through with first upfront good design techniques, making sure that we had a low noise design to begin with, but then putting the final touches on with starting out with a lot of copper tape to prototype things. I think we went through about $300 worth of copper tape, but and then making sure we had something that was also manufacturable. We ended up with a very good low noise design in the end.
We had several significant challenges. So one is, in looking at this display, while it's wonderful to provide a much larger display, 15.6-inch display, typically with a scope, what you'll find is about half of the face of the instrument is display and the other half is front panel. Well, on this instrument, we're about 85% of the face of the instrument is the display, which left a fairly small area over here for the front panel. And at the same time, we were also doubling the number of inputs.
We've always operated under the assumption that the customer needs one set of knobs per channel. And traditionally, on a 4-channel scope, that means you've got 4 sets of knobs to control each one independently. When we came up with the concept of doubling the number of channels that a customer could have, we continued with that same frame of reference. Except that makes a box that is very big, it's very clumsy, it's rather difficult to use, and it didn't look like what we expected. But what that forced us to do was then to try and understand how can we still allow the customer to control a channel, but reduce the number of knobs, the number of buttons, and that's where the multiplex design came in.
The reason the lighting is so important behind the knobs is that it gives the user the indication of which channel is active. So we do different things. We tell them which channel is active and they're controlling and which channel is being triggered.
So during early usability testing, we found that our customers expected to walk up to the touchscreen and interact with it just like a mobile device, with the pinch and zoom and the gestures on a mobile device. And we found that it was challenging to do that internally because you're operating on live signals and not just, say, a web page. And so our engineers got to work very quickly to change algorithms underneath in order to make the device operate more smoothly.
We are doing a much more in-depth analysis on the data sets that we get, and as a result of that, though, that you're crunching more data means you're taking more time to do it. And so we always had this concern that performance was going to be a challenge. And the team has spent a significant amount of their time over the last couple of years really focusing on how to optimize the performance in the system softwares in order to get the same responsiveness time as we've had in past products, but even so providing more in-depth analysis.
We had a big challenge in the middle of this project. We decided to change our approach to the UI using a different technology, and it required a lot of work from the UI team to redesign some of these controls so that they would look the same but use a different technology. And the primary reason we did that is because we wanted to, this is a big deal, and this UI is its foundation for going forward. It's beautiful, and we wanted to provide more flash, animations, dragging, things that would make it more interesting to interact with.
Just talk about the feet here for a second. So there's new rear feet that enable different viewing angles, but a finishing touch on the detail. Oftentimes customers take scopes and they lean them forward so that they can get to the back and change various I/O connections or things like that. And what you'll find on many existing scopes on the market is when you lean them forward like this, the feet collapse.
When the users were doing that, the scope would collapse over and over and over. And so that night, we're kind of sitting there after doing all the user testing, and we're talking with the ID firm and marketing. We're saying we have to solve this problem. So we put some time into it. We came up with a weight-activated foot. And so, when the instrument has a load on it, the foot will compress. And then as it compresses, it now locks and it won't actually roll forward anymore.
We have a milestone that we are working toward when we bring up a new system. And the milestone has a long history here at Tektronix. And we call the milestone the green worm milestone. Green worm is a reference to the old CRT-based oscilloscopes, and when the phosphor on the screen was green. And so the first time that an instrument is able to digitize a waveform and put it up on the screen with the triggered waveform view, we call that green worm. And so I do remember fondly working in a lab just like this late into the night and being able to be there at the moment when the green worm happened for this product.
Yeah, so in summary here, we're really proud of this instrument. I mean, there's so many firsts with it.
I'm in UI because I like to make people happy, and I think this is going to make people very happy.
The thing that I'm personally proud of from the software side is this team. I'm really proud of the way that this team of professionals has come together over the last few years, and they are focused on getting this product out.
So, one of the things I'm very proud of this instrument is that, it's going to be the first where we have fully integrated a tablet use model into a test and measurement device.
I do believe that this is going to change people's expectations for interacting with test and measurement equipment.
Once you try this, you're not going to want to go back.
Really, when you sit there and do it side by side with older products, you really notice the difference.
We have something to be proud of.